Okay, so we're starting with 1 or more x's to 1 y. And the very first thing for the warm-up, when it says evaluate, it's meaning you take this number and you plug it in right here. So we're going to, for number 1, we'll take 5 and we'll plug in 1. We get 5. We take 6 and we get 30. We take 12 and we get 60. We take 25 and we get 125. On number 2, we're going to take half of 1 and add it to 1. So half of 1 is a half, so 1 and a half. We take half of 6, which is 3. 3 plus 1 is 4. We take half of 12, which is 6. We add 1, that gets us 7. We take half of 25, which is 12.5. We add 1 and we get 13.5. Then, number 3, we take 1, we subtract 8, we get negative 7. We take 6, we subtract 8, and we get negative 1. We take 12, we subtract 8, we get 4, and 25 minus 8, and we get 17. Okay, so this next part, what's my rule? Okay, rule, you're writing an equation, guys. That's all you're doing is writing an equation. But before we can write an equation, we have to know whether or not we have, if it's a line or not. So, in order to do this, we look at this, okay? So, I look at this, and this is, it goes up by 12, goes up by 12, goes up by 12. This, it goes up by 3, 3, 3. So, my slope, 12 over 3, because it's the same each time, would be 4. My y-intercept is right here. So that means my b value is 12. So y equals 4x plus 12. Then over here, pick a different color. So this goes up by, or down, that goes down by 8. This goes up by 12. This goes up by 18. Over here, this goes up by 4. This goes down by 6. This goes down by 9. So let's see if it's actually a line. So let's look at this. Slope is negative 8 over 4, which is negative 2. So this is 12 over negative 6, which is negative 2. We have to check one more. And that's 18 over negative 9, which is negative 2. So our slopes, that is a line. So we have a line. Now, we don't have the y-intercept. We need that to be, the x to be 0. So we went back 1. If we go back 1, that means something minus 2 is going to get negative 2. That would be 0. So, negative 2x. Now, if you write the plus 0, it's not technically wrong, but we don't normally write it. Now, on this one, let's look at it. So, this goes down by 8. This goes 2. Oh, down by 2. This goes up by 5. This one goes up by 8, up by 2, up by 5. Now, the slope would be negative 8 over 8, which is negative 1. Negative 2 over 2, which is negative 1. 5 over 5, which is positive 1. Now, the thing with this is it's not linear. It does do something, and you can write an equation for it, but we haven't talked about what kind of equation that would be. So this is not a linear one. So we're just going to leave it as is because it's not linear. We can't do anything else with it because we haven't learned what else we can do with it. This one, it goes up by 2, by 0.5, by 7.5. This one goes up by 4, up by 1, up by 15. So let's look and see what our slope would be. So if I look at my slope, that would be 7.5. Oh, why am I starting at that very end? I don't know. So when I do this, I have 2, oops, I still have the eraser. 2 over 4, which gets a half. I have 0.5 over 1, which is, again, a half. And then I have 7.5 over 15, which amazingly is still a half. And then I have my y-intercept. So y equals 0.5x plus 2. Or you could write it as, and this is how I prefer it. Okay. And then that's a partner activity. And we're not going to do that, obviously, because I don't have a partner right now. Okay, so this next part, we skipped over the sequences, and so we can't really do that right now. But let's look at this. It says you can also use mapping to show ordered pairs. Mapping represents 2 sets of objects or items. The arrows connect the items to represent a relationship between them. Now, when you write the ordered pairs for mapping, you are writing a set of ordered pairs, and a set is a collection of numbers, geometric figures, letters, or objects that have the same characteristics in common. So we're going to be dealing with the fact that it's a set of ordered pairs. So before we can do anything, we have to learn how to make the braces. On your computer, if you look next to the letter P, you can do that. Now to write the open brace, you can write an S and then write a 2. And then a closed one, you write a 2 and then an S. So an S and a 2 and a 2 and an S. Okay. So here we go. We're going to write ordered pairs. So this right here is your X value or your input value. And all the inputs together are called the domain. Okay? These are your Y values. These are your output values. And the set of all your outputs are called your range. So I take 1 because that's my first number here. And if you look at it, 1 goes down to 7. Notice how the arrow, the ray starts at 1 and goes to 7. That means it starts at 1 for the X value and goes to 7, which is the Y value. So then I have 2, and 2 comes up here to 1. And 3 goes straight across to 5. And 4 goes up to 3. And there you have it. So we do the same thing over here. As I look at this, the 1 goes to 1. The 2 goes to 1. The 3 goes to 5. The 4 goes to 3. And the 5 goes to 7. Okay. So then we're going to go to this one. And we're doing the exact same thing. 1 goes to 1. 2 goes to 3. 2 also goes to 5. Do you see how it has 2 different arrows? It goes to both of those. 3 to 5. 4 to 7. And 5 to 7. Then we also have this last one. Goes 2 to 7, but it also does 2 to 20. 4 to 9, 6 to 9, and 8 to 2. Okay, right here. Now we're taking the ordered pairs and now we're making a map. So again, the x values go here, the y values go here. So 5, 6, 11. Oh, I forgot the 8. 8, oh, that was horrible. 8, 11. Notice how I wrote it in numerical order. It makes it much easier. 5, 8, and 9. So the 5 goes to 8, so 5 to 8. 11 to 9. 6 to 8. And 8 goes to 5. Okay, so we do the same thing over here. I have 3, 4, and 9. I have 4, 7, 8, and 20. My first point right here, 3 goes to 4. Then 9 goes to 8. 3 goes to 7. And 4 goes to 20. Then these are the easy ones. Why do I say that they're easy? Because guys, they're already in a row or already in a column for you. You don't even have to think about which one goes in which column or anything like that because they already have them in the columns for you. So negative 10 goes to negative 20. Negative 5 went to negative 10, 0 goes to 0, 5 goes to 10, and 10 goes to 20. And they had them in numerical order, so it really made it easy. So over here, I think I'll come down here and do it. Oh, that was horrible, but that's okay. So I like to go in order, so 0, 10, and 20. This said negative 10, negative 5, 0, 5, and 10. So let's see, 20 went to negative 10. 10 went to negative 5. 0 went to 0. 10 went to 5. And 20 went to 10. And voila. Okay, so our next part of vocabulary is questions 1 through 3. What we did when we made those sets are called relations. A relation is any set of ordered pairs or the mapping between a set of inputs and a set of outputs. The first coordinate is called the input. Guys, that's the x value. The second coordinate is the output. That's the y value. Now, before I go over function, I'm going to come down here. Domain is a function. The domain of a function is the set of all input values. So, guys, that's the x values. Range is the set of all the outputs. Those are all of the y values. Okay, so a function maps each input to one and only one output. This is super important to know. Each input, so each x value has exactly one output, one and only one output. So we're going to look down here, the domain. Guys, the domain are all these numbers right here. All these numbers right here. That's the domain. The range comes right here, just like we did just a few minutes ago. Those are the range. Now, if you look at the domains, 1 goes to one number, 2 goes to one number, 3 goes to one number, 4 goes to one number. It has exactly one, so one and only one output for each of its each input. Okay, so here, same thing. Now, if you notice here, 2 of them go to 3, but that's okay. 2 of them can go to 3 and it's still a function. Okay, let's come down here. Let's look at this. Again, we have our domain right here. That's our domain. We have our range. That's right here. But this is not a function because look right here. 2 goes to 3 and it goes to 5. So this is not a function. Not a function because is that spelled wrong? No, that's spelled right. Because one input, the number 2, goes to 2 outputs, 3 and 5. And by the way, this F should not be capitalized because it's in the middle of a sentence. Okay, now we're supposed to go back to number 2 and we're supposed to find the domain and range for each one of these. Now I'm actually going to do it on numbers 2 and 3 just so that I don't have to go back and forth, back and forth, back and forth. So we're going to go right here and we're going to write domain. And when you do that, you make a colon. And then you just list the numbers that are in the X values. So 5, 6, 8, and 11. The range values. The Y values. So 5, 8, and 9. So is it a function or not? Each one of these goes to exactly one Y value, so this is a function. Each X value goes to one and only one Y value. Now over here for this one, the domain for this. Again. Oops, sorry. We're talking about the X values, so 3, 4, and 9. We're talking about the range values. So 4, 7, 8, and 20. Now I look at and see if this is a function. I notice that 3 goes to 2 different things. Because 3 goes to 2 different things, that means it is not a function. Okay, so this one is not going to be a function. So, not a function because the input 3 goes to more than one output. 4 and 7. Okay? So if I look at this one, domain and range. Domain. Okay, so this one, -10, -5, -0, 5, and 10. The range. We have -20, -10, 0, 10, and 20. Okay, it is a function. Because each input, helps if I spell right, input has one and only one output. Okay, over here, I don't know, where am I going to write this? Domain. That was so horrible. There we go. I have 0, 10, and 20. My range. I have -10, -5, 0, 5, and 10. If you notice, 20 repeats, 10 repeats. So this is not a function because each input does not go to only one output. Okay, so now we can go back to where we were and go here. Okay, so now that we did that, it says review and analyze Emil's work. Explain why Emil's mapping is not an example of a function. Well, hopefully you look at it right here. Doesn't 4 go to 2 different things? So that is not a function. Okay, so sequences. Determine if each sequence represents a function. And I'm going to tell you right now that we didn't really go over this. So let me go over it here. This is the first term. So if I was writing a relation 1, 2 for this is the term and that is the number in the sequence. This is the second term. So 2, 4. Okay, so this one right here is the term. Yeah, I shouldn't write that because that might be wrong with my wording. Okay, oops. And then this is the third one. So this is 3, 6. This is the fourth one. So that's 4, 8. And this is my fifth one. So this is 5, 10. Okay, so down here, we would do the same thing. Okay. On this, domain would be 1, 2, 3, 4, 5. The range on this would be 2, 4, 6, 8, 10. Okay. And then, is it a function? Yes, it is a function. And I'm not going to do the mapping.